Back to our channel, guys. Hope you are doing extremely well, and this is your very own mask code at this side. So sorry for skipping the GFG periodic series for so many days. I was not feeling really well. I will be continuing the series from now on, and I promise you to be staying consistent with it. Okay, so today's question is remove half nodes. Remove half nodes. What do you mean by half nodes? The nodes with one children. Nodes with one child. Exactly one child. The node can have either 0, 1 or 2, right? We know that in a binary tree the node can have either 0 child, that is a leaf node, or 1 child, that is a half node, and a 2 child, that is a complete node. From these three options I only have to choose the half node. Okay, so if I try to explore the number of half nodes in this given tree, what are these? So if I try to explore them, so you can see that 9 have 0 children, so it is not a half node, but 3, it is a half node. Similarly here 8 is a leaf node, it does not have any children, so it is not a half node, but 6 is a half node, and similarly 7 is also a half node. These are the three nodes that these are half nodes, right? Now the question demands me to remove these. The question wants me to remove these. That is, they should no longer be the part of the tree, and my tree should look something like this. 5, correct it. Now 7 is not the part of tree, so I will skip the 7 and I will come to 2. That is, 2 will come here. Okay, 2 has 4 here. Now 6. 6 has to be removed, right? So 6, after 6 removing, it will be looking something like 8. And here 3 has to be removed, so 9. So this is my answer tree. This is my answer tree. You can check that in this answer tree there is no leaf node. You can check in this answer tree there is no half node, sorry. So how will I do that? How will I try to process it? How will I try to process it? See, the problem here is the main part where you have to think about is that this 7 can be deleted easily. There is no point in deleting 7. That can be done easily. But the main problem is that before deleting 7, I have to connect this 2 with this 5 left, right? This connection has to be made. This 5 has to be connected with 2 before deleting the 7. This 5 has to be connected with 2 before deleting the 7. So my approach says, if we are trying to go bottom up, if we are trying to go bottom up approach, if you're trying to go bottom up approach, that means if you try from the leaf nodes, that is the last nodes, and then go up till the root, then go up till the root, that is, if you process 4 first, if you process 8, then if you process 9, then if you process 6, if you process 2, if you process 7, if you process 7, if 3, if you process 5, then things might fall into place, right? So what I'm trying to say is, for the tree, that 5, 7, 3, 2, 4, 6, 8, and here is 9. This is a tree given to us. My approach says that go in the bottom up approach. That is, somehow you reach 4 first. In the recursion call, we all know that there are 3 types of traversal. We all know there are 3 types of traversal, right? So we'll have to use any one of them. I will have to use any one of them. Let us see what we require, right? 4. I come to the 4 and I see, is it a half node? No, it is not a half node. So stay as it is, return 4 only, right? Moving on. 8. Is it a half node? Yes, no, it is also not a half node, it is a leaf node. So stay as it is. 9. Is it a half node? No, stay as it is. 6. Is it a half node? Yes, 6 is a half node. So what will I do? I will have to remove this 6. But before removing this 6, you can see, because this is a half node, that means either left is null or right is null, right? That means if left is null, then I will have to send this 8. That is, instead of returning 6, that like I was returning 4 here, I was returning 8 here, I was returning 9 here, right? Now 6, no, that my bottom tree has been processed, right? So 6 will say that return this root, right? Instead of returning 6, return this 8. So it will also return 8. So in this manner, this node has been deleted and 2 has been connected to 8. 2 has been connected to 8. Moving on, coming to 2, coming to 2. 2 will now be 4, 8. You will not, it is not a half node. Moving on to 7. So it will also return 2 only. It will return itself only. Moving on to 7. 7 will say that 2 is fine, but my right child is null, so I am a half node. So it will also say that I will have to be deleted. Now because the right child is null, there is nothing present here, so it will say that I will also return 2. I will also return 2. As soon as it returns 2, 5's left is gonna become 2. This connection is gonna break off and this connection has got to be formed. Right. Similarly here, 9 returns itself to 3, and 3 will say that my left is null and my right is not null. That means 9 has to be connected to 5. That is, it will also return 9. So 5 will break this connection and form this connection, right? So my final tree will look something like this: 5, 2, 9, 4, 8. Right? I hope you are understanding the approach. That is, if I'm going from bottom up, I already know that my bottom nodes are processed, so I don't have to worry about them. I just have to worry about myself, right? And I can return them easily. Now, how to go with the bottom up approach? So we know there are three types of traversal. First type of traversal is pre-order, which says process the root first, then go towards left, then go towards right. Similarly, in order says process the left first, then go towards root, and then go towards right. And then the post order says first process the left, then process the right, then process the root. Right. So if I try to pick out of these three, so first option is pre-order. Can I pick out the option from pre-order? No. Why? Because I want to process left first, right first. That is, before the root, I want to process both this. I want to process both this. So it is not a valid option because root is getting processed earlier than both its children. Similarly, here left is getting processed. I know that, but right is getting processed after the root. Right? That is also not acceptable. But here, in the case of post order, left is getting processed, right is getting processed, and root is getting processed in the last term. Root is getting processed in the last term. Now, if some of the students want to like mix it up, you can also do something like this: right, left, root. You can also go by this method. Nothing problem in it. It is also fine, but it is not a conventional method like post order says left, right, root. It is not a like this method. This traversal does not have a name, right? But it would also work very fine because the logic is same. I just want to process the children first. Just want to process the children first, and then come to the node, and then come to the node. So what is my pseudocode saying? What is my pseudocode saying? My pseudocode is simple. Suppose I have a function f which takes my root, right? First base case is if my root is null. If my root is null, if somehow I come to a null node, return null, return null, right? I don't have to process a null node. Second case is that if my root is a leaf node, that is its left child is also null and its right child is also null. Root left and don't forget to use the AND operator, root right. In that also is return, in that case return root, because root is a leaf node and I don't want to delete the leaf nodes, right? Moving on, if root left is not null, if root left is not null, right? Oh, sorry. You have to process. You have to process the previous case. That is, if you have to process the left case, then right case, and then come to this part. That is your root left, your new root left. As you were saying, na, that we made the new connection. So root left is getting change of 5. So root left will now be f of root left. F of root left. That is, process the left part first. And similarly, root right is gonna be f of root right. Process the second part first. Now, okay. After these both have been done, after these both recursion calls get completed, then what will you do? Now, after processing the both the children trees, what do we say? If my root left is null, if my root left is equals to null, what does that mean? What does that mean? If root left is equals to null, and this condition says that root right is that both of the nodes are not null at the same time, that means root right is not null. In that case, return root right. Return root right. Right? And similarly, if root right is not null, root right is null, sorry. In that case, return root left. Now the only case left is that the node is complete. That is, the node have two children. In that case, return root. Return root. Right. So what will happen? It is going to check for the null case. It is going to check for the child node, leaf node. It is going to process the left subtree. It is going to process the right subtree. It is going to check if it is a half node and return the results accordingly. And if it is not a half node, return the root, because that is what you are supposed to do. So I hope that is fine with you, and we can move to the code now. The coding section, Before starting with the code, I would like to request you to please subscribe to the channel because it really motivates me, right? Moving on, if my root is equals to null, that is null node has arrived, so return null. Now process the left subtree. So root left is gonna be the same function, that is remove half nodes of root left. Similarly, root right is gonna be the function remove half it is correct spelling, yeah, remove half nodes of root right. Now when I know that both the left and right subtrees have been processed, now it's time to look at the current node, that is if root left and root right both of them are null, in that case return root. If both of them are null, it is a leaf node, you can return it safely. But if my root left is null, in that case return root right. And if my root right is null, in that case return root left. In that case return root left. Now moving on, what will happen if both of the conditions have not worked? That is the current statement has not been returned, the current function has not been returned. That is, this is not implemented, this is not implemented, this is not implemented. That means the node is a complete node. And you can simply say return root, right? Let us try to compile and run it. Hope it will work fine and not give any error. It is working fine for the sample test case. Let's try it for the hidden test case as well. In the meantime, do consider subscribing to my channel because it really motivates me, right? Okay, so 218 days streak. Thank you for watching my video and so sorry for being so late. So I will try to be early as possible in the following days. Thank you. Have a nice day.